Okay, here we go. Multiplying polynomials, part 1. So in this unit, and throughout all of your math career, because you're going to be seeing a lot of polynomials, we're going to express them in two different forms. We're going to express them in simplified form and also in factored form. So I'm just going to get my pen out here. So simplified form and factored form. When we multiply polynomials, which is what we're doing today, we always write our final expression in simplified form. So what's that mean? A polynomial is in simplified form when all brackets have been expanded and it is expressed as a sum or difference of terms where all the like terms have been collected. So some examples. 3x minus 6, 6x squared plus 17x minus 14, 2x cubed minus 8x squared minus 10x plus 1. So why is this expression not in simplified form? And it's kind of rhetorical. I'm going to answer that. We have these x terms which need to be collected together. Okay, we're all back and all like terms have been collected. So this will be 3x squared. X plus 9x is plus 10x minus 5. Clean that up. That should be a plus, not a t. So far, you've only learned to multiply a monomial by any polynomial. That's in the grade 9 curriculum. So let's just do a quick review of that. Simplify, and that's your instructions, right? We can't solve this. There's no value for x. It's not equal to anything, so we simplify. So you're going to multiply using the distributive law. So we get 15x squared minus 6x plus 3. And on this one we get a times 2a is 2a squared minus 7a. And I think we can put some equal signs in here to show that this is equal. This lesson we're going to focus on multiplying a binomial by a binomial, and that's something you need to get really good at. You're going to be doing a ton of these, not just for practice during in 10C, but as as a tool in solving things throughout the rest of your math career, both in high school and post-secondary. Okay, so we're going to do a little demo on algebra tiles. You don't have this on your sheet, but you can watch it here, and of course you can come back and watch anytime. Remember, the area of a rectangle is length times width. Formula A is equal to L times W. Okay, so now you're just sitting back and watching. Just watch the following examples. You only have worksheet notes for the exercises. Those will be coming up in a little bit. So, if the square shown has an area of 1, then the width and the length of the square are both 1, right? Area is length times width. 1 times 1 is 1. Make a rectangle that has an area of 6. Okay, now I think, put that down. I need to switch to a pointer here. I think I can pick the, oops, nope. Let me get rid of that. Oh yes, so I can drag this over here and make a rectangle that has an area of 6. And I'm just going to show you here on this, and then on some future ones. And this is not going to be the world's greatest rectangle, but and then on future ones I'll pause while I drag stuff over. Here we go. So an area of 6 means 6 square units. Each of these is 1 square unit. We've got 1, 2, 3, 4, 5, 6. Since area is length times width, we can express this area as a product of its length and width. So pick up, put it back to a pen. So A is equal to L times W. It's got a length of 3. So A is equal to 3 times 2. Nice, 2. And A is equal to 6. Okay, and really that's 6 units squared, right, or square units. Is the rectangle above the only one that can be made that has an area of 6? No. If not, make another rectangle with an area of 6 and then express its area as a product of its length and width. Okay. 1, 2, I had it in place. 2, 3, 4. No perfection here. I mean, if these were actual physical tiles, which of course you can work with. How many do I have? 1, 2, 3, 4, 5. One more, and we have an area of 6. And what is that area? Oops, pen. Area is length times width. My length here is 6, and my width here is 1. So that's 6 times 1, which is 6. And again, units squared, and I, whoops, obviously can't write, so I might just leave off units squared from this point. We'll just realize that we are talking about an area which would be measured in square units. If the rectangle shown has an area of x, and the width of the rectangle is 1, then what is its length? Well, area is length times width. Anything times 1 is itself, so its length is x. Make a rectangle that has an area of 4x. Okay, pointer. So 1x, 2x, 3, let's move this down here, 3x, 4x. There's an area of 4x. And what are its measurements? Well, how far is this? It's 2x. And what is this measurement? It's 2. Because remember, the width is 1. That's 1 plus 1 is 2. Express area as a product of length times width. You notice I'm going to write the formula down each time because that's how, wow, things are not writing well here. And we get 2x times 2, which is 4x. That has an area of 4x, right? Each green bar has an area of x. Can you make another rectangle that has an area? Yes, you can. So the answer to this is no. If not, then make another rectangle and express it as a product of two monomials. Oops, I was supposed to have a pointer. 1x, 2x, 2x, 3x. Let's drag this one over here. So there again, now we have a rectangle with an area of 4x. And actually eraser, let's get rid of this line. And back to pen. So what is the length? Well, 1, 2, 3, 4x. What is the width? There's a width of 1. Area is length times width. Write the formula, width. Write the formula down every time, every time, every time. Okay, and I'm going to say area is 4x. I'm not going to write units anymore or units squared, but we need to understand area is measured in square units. If the square shown has an area of x squared, then the length and the width of the square, well, it's a square, so they've got to be the same, and they're both x. X times x gives you x squared. Make a rectangle that has an area of 3 of these. 1 of these, 2 of these, 3 of these. Length of the above rectangle is 3. Oops, need a pen. Okay, we got 1x, 2x, 3x. Nice 3. Wow, something's going on with the pen here tonight. And the width is x. x. Express the area as a product of its length and width. What did you say area was again? Length times width. You write the formula out every time you do. So formula, substitution, and answer, 3x squared. In this case, really the squared's in there, but you know, it's 3x squared units. Exercises. Hey, this is where we catch up. You can follow this along with your worksheet. So how do these rectangles compare? I don't know if I can pick one of these up. Let's see if I can pick one up. Nope, I can't. But you notice that their width is the same. So they have the same width. Oh, you know what? Actually, let's call it length. They have the same length. So here we're talking length as in this. Right. Each length is x. How do these rectangles compare? They have the same width. They have the same width. Since these rectangles have some common dimensions, we can combine them together when making rectangles, right? So, you know, I can put this, I got a bug on my screen, I can put this over against here, or I can turn it sideways and put it along here, and I can take this and put it along the edge here. So we can do that, and we can combine them when making rectangles. So what's the area of this rectangle? Well, this area is x, 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 so that's 3x, and 1, 2, 3, 4, 5, 6. So we have 3x, it's x, I think x is better, plus 6. Let me clean up the x. There, nice, dark. The length of the rectangle, well, that's x plus 2. Oops, I wanted to go that way. And the width of the rectangle is 3. So the length is x plus 2. And its width is 3. Now, let's see if I can bring stuff up here. No, got it right. So, the area can be expressed as, let's go here. So remember, area, well, let's write that up here. Area is length times width. So it's x plus 2 times 3. Okay, you know what? I'm going to write the 3 in front. So it's 3 times x plus 2. That's factored form. We have brackets, right? And we want simplified form, which is 3x plus 6. Hey, using some math, we got the same idea as this picture of the area where we could count 3x plus 6. This example shows the simplified form of the product of a monomial, one term, by a binomial, 2 terms. So monomial, 1 term, binomial, 2 terms. The area of the rectangle below is, okay, what do we got? We got 1x squared, 2x squared, 3x squared. Okay, so I'm going to write that down. We have 3x squared. How about we got 1, 2, 3, 4, 5, 6, and there's one tucked in here. So plus 7x and 1, 2. Plus 2. The length of the rectangle, well, x, 2x, 3x, plus 1. So 3x plus 1. And this width is x plus 1 plus 1, which is x plus 2. So the length of the rectangle is, where's my pen? 3x x plus 1, and the width is x plus 2. This area can be expressed as, so remember, area is length times width. 3x plus 1 times x plus 2 is the factored form, and the simplified form we have up here, right, which we found just by counting. So it's 3x squared plus 7x plus 2. 3, nice. I don't know, there's some lag in here. 3x squared plus 7x plus 2. And what are we multiplying together? We've got binomial, binomial. So it's the product of two binomials. And so these two things must be the same. And really the question we're going to be answering is, how do we turn this into this? Now, we have a concrete or pictorial model, right, modeling it with algebra tiles, and we don't have enough to go around, so if you want some to play with, then, you know, come see me and we'll grab you a set and you can play with them yourself and make up different rectangles and figure out the relationship between factored form and simplified form. Use algebra tiles to find the areas of the rectangles with the following lengths and widths. Since the lengths and widths given are binomials, this is one method of multiplying a binomial by a binomial, which is the main outcome of today's lesson. So I want 2x plus 1 times x plus 3, and I have some tiles hanging around down here. So I need to switch to a pointer. And you know what I'm going to do with the 2x plus 1? I'm going to move that up here so we can say, okay, I've got x, 2x plus 1, right? And then on the side, for the width, I've got x plus 3. 1, 2, 3. Wow, there is some lag here. It must be what's going on with the writing. So when I multiply x by x, then what's going to fit in there, right? In here, see that? We got this x squared. And we've got this again. We got another x squared here. Down along here, that's going to be this little x here. What about over here? Well, I can fit an x here and here, whoops, and here and here and here and here. Clean this up a touch. Move over. And then we've got this little strip to fill in here. Well, I can't fit an x in there. See? Look, x, too big. Okay, so let's put that back. But I can fit some 1s in here. So 1, 2, 3. Oops, 3. Okay, so what have we got? The area, the factored form, is to say we're multiplying length times width. Oh, gotta get a pen. Give me a pen. So factored form is length 2x plus 1 times width x plus 3, and the simplified form, well, we have 2x squared. We have 1, 2, 3, 4, 5, 6, 7x and 3 1s, so plus 3. And we're going to do the same thing here. So I want 3x plus 1, so I'm going to draw a line. Get rid of that. I need my pointer back. So I want to put in 3 x's. Okay, now I'll be back. I'm going to pause. I'll be back. I'm back. So what have we got here? 3x, 1, 2, 3 x's plus 1. Oh, I'm going to go back to a pen. So this is 3x plus 1, and this is x plus 2. I suppose I should have written that over here, right? This one is 2x plus 1, and this was x plus 3. Wow, the pen. Okay, so now I want to go fill this in area-wise, right? So we can fit an x squared block here, another one here, another one here. I can go with an x that will fit in here. I can fit these guys there, 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 and there. Take that. A little lag going on here. Actually, got a lot of lag going on. And then all we can do to fill this in is a couple of ones. Okay, give me a pen. Go back up. So our factored form, 3x plus 1 times x plus 2. Our area form, we got 1, 2, 3x squareds. 1, 2, 3, 4, 5, 6, plus 7x. And 2 ones, plus 2. Okay, so there's our area form. This is a concrete model of doing this, and what we want to do is work our way towards an abstraction, which is where we no longer need the model. But, you know, I mean, if you want to play with these for a while, you can, and I will make this file available to you, and you can open it with Smart Express, and then you can play with it yourself if you want. You'll have, you know, some virtual tiles to play with. And here's a page which you can do that on, right? We've got some x's and some x squareds and 1s, and, you know, you can build length here, width here, and away you go. Now, video only bonus. Only on the video, so in class we're going to kind of skip by this, but the gray rectangle below has a length equal to x and a width equal to y. So the area of the rectangle is, I think this actually reveals here, x times y, known as xy. So this area is xy. Now, can we use the x and y pieces to make a rectangle that has a length of 2x plus y? Okay, so hang on, let me do this. Let's get a length. So I want 2 x's. So 1x. I'm going to put my length up top here, right? 2x plus y. And a width of, so I'm going to need my sideways guys here, a width of x plus y. And then let's see what we get. Well, in here we're going to fit a green x squared. Right? So we have x times x. And in here we can fit an x squared. And in here we need something that's y wide but x long. So hey, look at that, right? Because it's y, x. And that's what we have over here, right? We got x on the side, y up top. Now we have a y and an x, so I think this is going to fit in here. Yeah, very nicely. And then this will fit in here also very nicely. And what do we got here? We've got y and y. So how about that? Hey, take a look at that. So we have a length of 2x plus y. Let me get a pen here. Length of 2x plus y. A width of x plus y. When we multiply those together, so remember, area is length times width. which is 2x plus y times x plus y. And what do we have? We have 2x squared. So remember, this is the factored form, right? Area form, length times width. This is the area, that's the simplified form. 2x squared. Now, hey, what have I got? I got 1, 2, 3 of these guys, plus 3xy, and one of these guys, plus y squared. And again, so what we want to eventually do is get away from the concrete or pictorial representation of this and get to an algebraic abstraction of it, where we just deal with the x's and y's and come up with some rules. So that's that example, and here's a page where you can play with. You've got every possibility, right? X's, y's, horizontal and vertical, you've got x, y's, horizontal and vertical, you've got x squared, y squareds, and 1's. So, you know, you can come back to this page and play with it with any of the examples that we might be doing. And that's your video-only bonus. Maybe some special music there, but I don't have it, so. Okay, back to the worksheet. Multiplying binomials. How can we write the product of two binomials in simplified form without using algebra tiles? So using algebra tiles, we found that 3x plus 1 times x plus 2 was 3x squared plus 7x plus 2, right? You can go back and look it up, you'll see that. Now, if we explore the terms in the two binomials, we've got a 3x and an x, or a 3x and a 1, we've got an x and a 2, and if we look at the simplified form, you'll see we've got a 3x squared and a 2, and we've got a 7x. So we want to figure out, how do we get this same result by multiplying the individual terms? In class I will pause here and let you think about it. You could pause here for a while and think about this and then decide, how can I get from this form to this form using some algebra? Okay, so pause now, think about it. Okay, you're back. So I'm going to show you how this is done. So if we multiply the 3x times the x, so here, let me write this out. 3x plus 1 times x plus 2. So if I multiply 3x times x, that's going to give me 3x squared. Now you might also see, hey, if I multiply 1 times 2, that's going to give me the 2. How are we going to get this 7x? Well, we're going to go 3x and multiply it by 2. And what does that give us? That gives us 6x. And now we're going to go back and we're going to multiply 1 by x, which gives us 1x, which we're just going to write as x. And then we have 1 times 2, and that's where our 2 comes from. So you notice our first term in the simplified form comes from multiplying the two first elements of the binomial together. And our last term comes from multiplying the two last elements together. And our middle term comes from multiplying the outside numbers and the inside numbers. And then we have a little bit of work to do. One more step. We have to collect like terms. So we get 3x squared plus 7. Oh, horrible 7. I've got to clean that up. Maybe the disk is getting full. I'm getting some lag here. 7x plus 2. And a lousy 2 out of that too. When multiplying two binomials together, you can use the acronym FOIL. FOIL stands for first, multiply the two first terms together. Outside or outer, multiply the outside terms, the 3x times the 2, giving you the 6x. Inside terms, or inner, 1 times x gives you x. And then last terms, 1 times 2 gives you 2. So first, outer, inner, and last. And you write your own it's legible a little bit. If this procedure is done correctly, then that means that this factored form and this simplified form always have to have the same value. Verify this is true, choose a value of x. So you choose, pick a reasonable value. So I'm just going to go with x equals, let's go with 4. Now, you're going to work your own out. So in class, you'll be working your own out. But here, okay, so 3 times 4 plus 1 times 4 plus 2. That's 12 plus 1. Okay, let's throw an equal sign down there. So that's 13. 4 plus 2 is 6. 13 times 6 is 78. 8. Okay, over here, I'm going to put a 4 in. 3 times 4 squared plus 7 times 4 plus 2. That's 3. 4 squared is 16. 7 times 4 is 28 plus 2. This is 48 plus 28 plus 2. And I'm going to string this here. So 48 plus 2 is 50, plus 28 is 78. Or 28 plus 2 is 30, plus 48 is 78. And in both cases, these are the same, which means that this value, or this factored form, must be the same as the simplified form. Okay, moving on. This one's a long lesson, but it's very, very, very important. Find the product of the following binomials. Write your answer in simplified form. Okay, so I'm going to use FOIL. X times x is x squared. Outer x times 5 plus 5x. Inner plus 3x. And last plus 15. We can go downtown and get over a street. X squared plus 8x plus 15. Okay, let's keep going. So first, c times 2c equals 2c squared. C times negative 1 is minus 1c. We don't write a number when it's just a 1. Okay, so that's the outer. Inner, 4 times 2c is plus 8c. And last, 4 times negative 1 is minus 4. Now the only terms you're collecting are the inner and the outer products. Holy. So we have 2c squared. We collect these two. Minus 1c plus 8c is plus 7c minus 4. 5x times 5x is 25x squared. Outer, minus 10x. Inner, also minus 10x. And last, negative 2 times negative 2 is plus 4. This is actually a special product. We call that the square of a binomial. Since these guys are the same and we're multiplying them together, we are squaring a binomial. And we will learn how to do that in a very easy way. But not right now. Right now we're just practicing. These two terms, they actually have kind of special name. No, they don't. They're just, we got 7 plus 4y, 7 minus 4y. Okay, let's multiply it out. 7 times 7 is 49. 7 times negative 4y minus 28y. Plus 4y times 7. Well, that's plus 28y minus 16y squared. 4y times negative 4y. So you see why we spent all that time on roots and powers, right? You got to multiply. 4 times 4 is 16. Y times y is y squared. Okay, let's collect. 49 minus 28y plus 28y is 0. So then we're just left with minus 16y squared. This actually does have a special name. It's called a difference of squares. Difference meaning we're subtracting, and squares meaning these guys have square roots, which happen to be the numbers. This is a very special circumstance. You'll get to know it very well. First, 12r squared. I'm just going to kind of zip through a bit. Plus 20r minus 27r minus 45. Okay, so no big explanation required here. This will be minus 7r minus 45. Okay, this time we have combined x's and y's. Remember what we did with the algebra tiles? You could do this, but let's try and just FOIL it out. First times first, that's 2x squared. Outer minus 3xy inner plus, notice how they're both positive, the 4y and the 2x, so plus 8, and we're going to write this as xy, so we're always going to put our terms in alphabetical order so that we can see, hey, these are like terms, right? We're going to collect them, and we've got plus 4 minus 3 gives me minus 12y squared. Simplifying, 2x squared plus 5xy minus 12y squared. Okay, 3 more and then 1 more page, and you know this is longish, but you know it is vital. So what does it mean to square something? It means to multiply it by itself. Now we'll be looking at a way to do this quickly, but right now we're just going to write it out. So you write it as a product, right? And then we'll FOIL it. So 4x squared plus 6x plus another 6x. That's actually kind of interesting, right? Plus 9. Collect 4x squared plus 12x plus 9. And we're going to eventually find a pattern in this and find an easy way to square a binomial. But one thing, always remember this. There will always be 4 products, right? That's FOIL. 4 products. First, outer, inner, last, no matter what. 1 times 1, that's my first. Minus 3m, that's my outer. Minus another 3m, that's my inner. Plus, we have a negative times a negative, plus 9m squared. Now when it comes to writing this out, we generally like to write out the squared term first, so 9m squared. Minus 6m, we're collecting the like terms, plus 1. And last, what do we got? 4x plus 5y times 4x plus 5y. Yee. Okay, first, 16x squared. Outer plus 20xy. Inner, hey, look, again, we have plus 20xy. And last, positive times a positive gives me plus 25y squared. Collect it together. Now in this case, we're going to start with the x squared, then go to the xy term, and then go to the y squared. Okay, and I leave that up for half a second. You can always pause here if you want to look at it. And you know, we're almost 40 minutes in, so let's keep going. The width of a rectangle is 2x plus 5, and the length is 4x minus 3. And I can't see where my pen is. Determine the algebraic expression for the area. So area is length times width. Okay, done 100 of those. Is equal to 2x plus 5 times 4x minus 3. And remember, we want simplified form. This is factored form, right? Factors are things that multiply together. So, FOIL, 8x squared minus 6x plus 20x minus 15 equals, it's like this thing's running out of ink or something, 8x squared plus 14x, so we're collecting these middle terms, right, minus 15. What is the area of the rectangle when x is 3? Well, you could put a 3 in here, or you can put a 3 in here. They're going to be the same, right? Let's try it. If we put 3 in here, 2 times 3 is 6, plus 5 is 11, and this is 12, minus 3 is 9, and 11 times 9 will be 99. Now, will that work here? So area is 8 times 3 squared plus 14 times 3 minus 15. Well, that's 8. 3 squared is 9. 3 times 14 is 42 minus 15. I'll go over here. So it's 72 plus 42 minus 15, which is, what do we got? 114 minus 15. Throwing equals in there. Which equals 99. Now, I don't really like it when you string equals and go like that, but there's not much room here, so in that case it'll be okay. Triangle has a base equal to 2x plus 8 and a height equal to, if we drew this, we could draw this, right? A triangle, base is 2x plus 8, and the height is x minus 2. So I might show that like that, right? There's height, the perpendicular distance is the height. Determine the algebraic expression for the area in simplified form. So area is 1/2 base times height, which is 1/2 of 2x plus 8 times x minus 2, which is 1/2. Now, what I'm going to do is I'm going to FOIL this out. So we've got 2x squared minus 4x plus 8x minus 16, which is 1/2 of, now we're going to collect this, right? So we have 2x squared. Remember, the first and the last terms never collect or simplify, only the middle, plus 4x minus 16, so half of that, half of 2x squared is x squared. Remember, we're distributing this, right? Plus 2x minus 8. And all of these are the area, right? You can write area all the way down the list. Okay, last thing. Write numbers in the boxes so the left side is equal to the right side. So we know, using FOIL, that the first term, the x squared, only comes from that. We have a 9x and a 7x. So 9 plus 7 is 16, and 7 times 9, that's 63, only comes from the last two terms. X plus 5 squared. Okay, think about that for a sec. This is what it means. So our last term comes from just 5 times 5. It's going to be 25. And our middle term comes from 5x plus 5x, which is 10x. Okay, how do I get negative 5? Well, it only comes from the last term, and it's something times 1 gives me 5. So that'll be a 5. And this first term, the x squared, only comes from the first terms multiplied together, and that'll be 2x squared. Okay. Now, I suppose ideally I should have said, hey, you should be doing this on your own, and then you can come back and check. Okay, 3x times x gives me 3x squared, so there's a 3 in that box. 1 times something is negative 2. Well, the only thing that 1 times something gives you is, in fact, a negative 2. And the middle term, well, let's see, that's the combination of minus 6x plus 1x. Minus 6 plus 1 is minus 5. Okay, let's fill it in. 2x times what? Well, that has to be a 5 to get the 10. Plus 13x. Ooh, so we've got to figure this out, right? We're going to go with, okay, what will this give me? This is 2x minus 2x. So minus 2 and what gives me plus 13? So you might go over here and say minus 2 plus what is equal to 13. So that what is 15. And I've got a 5 here. How am I going to get a 15? I'm going to put a 3 here. So let's check this out. 10x squared minus 2x plus 15x is plus 13x, and this will give me minus 3. And really, if I was given this, that's how I multiply it out, right? I go 10x squared, I know that's the first term. I go minus 2x plus 15. In my head, I go minus 2 plus 15 is plus 13x, and then I go minus 3. And just basically write out the the final answer without writing out this split into two terms. Okay, 4x squared. Well, I got an x times something has to give me 4x squared. I need a negative 9. I've got a negative 3, so that has to be a positive 3. Okay, and now we can multiply it out. So 4x squared minus 3x plus 12. Minus 3 plus 12 is plus 9. And then positive 3 times negative 3 is minus 9. And that's the end of that in one of our longer lessons to date, hitting 47 minutes and running over 47 minutes. But hey, sometimes that's the way it goes. And we're done.